Hello, everyone, and welcome to CDO Magazine interview series. I'm David Boone, Associate Publisher here with CDO Magazine, and we are partnering with the MIT CDO Symposium and the International Society of Chief Data Officers in a series of interviews. Today, folks, I have a pleasure of interviewing Richard Brown from R3. And Richard's going to tell us a little about his company, a little bit about how his company is working with CDOs, and we're really kind of interested in seeing how R3 is doing that. So, without further ado, here's Richard Brown. So, Richard, can you just kind of start out, tell us a little about yourself, what you do at the company as well, and a little bit about R3.
Thanks, David, and thanks for having me. Yes, my name is Richard Brown. I'm Chief Technology Officer at R3. R3 is probably best known as the leading enterprise blockchain firm. We're the team and the firm behind Corda, the enterprise blockchain, and I led the team that designed, built, and brought it to market. More recently, R3 has expanded its range of products in multiple dimensions, and the one that's most relevant, I think, to this conversation is the second product that I've led a team to design, build, and bring to market, which is Conclave, which, as we'll come on to talk about, is a confidential computing platform.
Excellent. So, Richard, can you tell us, how data sharing without sacrificing data privacy as possible? How can you tell us a little bit about that?
Yeah. So maybe before we get to the sort of like the corporate domain where CDOs and other CXOs live, let's just think, or I like to think about our personal lives. So imagine after you watch this video, you click on your Chrome browser or Safari and you head over to Facebook.com. You may not be doing it sort of consciously, but subconsciously your brain's looking for that little padlock. We've all been trained for 10, 20, maybe more years to look for that padlock, because that's how you're secure. Right? You go to Facebook.com or you go to your bank, you type it in. And the way you really are talking to that big social network in Mountain View is because next to Facebook.com is the padlock. And the padlock tells you two things. It tells you you're talking to Facebook.com, the social network, and it tells you that nobody can intercept your data as it goes from you to them or from them back to you. The data really is protected as it moves, as it's in transit from you to Facebook. And this is something we never think about, but it's kind of mind-blowing, and it's just sort of like, it's just hard to comprehend when it finally sort of drops into one's brain. Once that data arrives at Facebook, they can do whatever they like. And of course, the rumor and the accusation from some quarters is that's exactly what they do. So we're kind of in this really weird situation where the IT industry has spent all these years building security techniques to protect data whilst it's sitting on your hard disk, and to protect it whilst it's moving from A to B, and to make sure it gets to the right place. And we've trained individuals and corporates to use these technologies and to complain if they're not there. And then just as we think we've solved the problem just at the last mile, as soon as the data arrives at the other end, suddenly all bets are off and the recipient can do what they like. So the question that the IT industry asked itself, and it was primarily driven by the hardware industry, and I'll talk about where R3 and our software fits later. But the problem and the idea that the hardware industry had was, well, what if we could go one step further? What if, when you're sending your data from A to B, and now imagine you are the CDO, you've got some customer data in your organization that you need to send somewhere else. What if, when you sent it to that third party, not only were you sure it was they who were going to receive it, but you could know in advance what they could do with it? It's almost as if you could put that data like in a box, send it to them, but it's controlled. They can do this, but they can't do that. You can control it whilst it's in use by somebody else as well. That's the promise of confidential computing. Now, it turns out that we're a long way from that at scale, absent technologies like Conclave, for a whole variety of reasons that we can get onto. But that's the key insight. Today, when you send data to somebody else, as a corporation or as an individual, you cannot control what they'll do with it. Technologically, you rely on law, contracts, GDPR, that kind of thing. Confidential computing gives us it gives us this potential, if we can harness it, to know not only that it's getting to them securely and it's getting to them and no one else, but that you know what they will do with it. That's the promise, and it could change the world when it's rolled out.
Wow. Well, why is this so important, or why would this be so important to CDOs?
So you're a chief data officer, and you're responsible for your firm's data. And there's lots of aspects as a CDO you have to worry about. There's are you getting the most from your data? Are you mining the information you can? Are you giving your customers the best possible service based on what you know about them? There's that aspect of the job, but then there's also the regulatory aspect of the job. When you send that data to somebody else, a third party for processing, can you be sure that it's being handled correctly by that third party? So there's that part of the job. And then the third thing you have to worry about, and this is where I think the opportunity really is, because today as a CDO, you really can't be sure what's going to happen to that data when you send it somewhere else. If we're being honest with ourselves, we can't always be sure what's going to happen to it whilst it's within our own four walls, because these are big organizations. And because of that, there's a whole bunch of things that we don't dare do. It's just too risky. It's too scary. So we don't participate in industry utilities where our data could be pooled and aggregated with that of our competitors and peers to find some new insight that could help everybody in the market. We don't participate in opportunities to find fraud by aggregating different data sets because we fear what would happen if the party who did that could use that data against us or to secure a monopoly position. So for me, the opportunity that presents itself to us isn't just, and it's not a small thing, but it's not just about securing what you have. It's about unleashing you and enabling you to take advantage of things that would otherwise just be too scary. So that's a bit abstract. Let me just give one really simple example, if I may, and this is from the insurance industry. So and I like to think I'm a good person, but if I was a bad person, I wish I'd thought of this way of stealing money. And it goes as follows. Imagine you wanted to steal money from some insurance companies. What could you do? Well, buy a car, just middle of the range car. It doesn't really matter. And it doesn't matter because you're going to totally total this car. You're going to destroy it soon. But before you do that, you take out insurance because, it's a car. It needs to be insured. But you don't take it out with one insurer. You take it out with 10. So you buy 10 insurance policies, perhaps $500 a pop. It costs you $5,000 plus the cost of the car, maybe 10. So you're $15,000 down. But now what you're going to do is you're going to total that car and you're going to claim against each and every one of those insurers. Maybe you get 8K back from each. 80K minus a 15K outlay, you just made 65K pure profit, simply and solely because those 10 insurance companies don't realize they've all insured the same car and they're all processing a claim for the same fake accident. And it's because they don't dare share the data, especially in continental Europe, because they have to be very, very sure that they're not violating the individual customer's rights. But imagine if they could share that data, and it's not very much, just the information that I, an insurer, am processing a claim for the car with this identification number in this time period. Imagine if they could share that somewhere centrally, and all that central service did was just look for matches. Hang on, this car is being the subject of 10 separate claims in the same week. Something dodgy is going on here. I'll let them know. That's fine, but every single claim would have to be sent there, and that would be a privacy breach, and it would be a massive source of power for the company who runs that. Fast forward to confidential computing. This exists. A startup has delivered a solution called ClaimShare, and what they do is they run that really, really simple algorithm, just looking for matches, but they run it inside an enclave, as it's called, inside a confidential computing system, and suddenly the opportunity to detect the fraud is solved, because the insurers know when they send this information, this claims data, the only thing that's going to happen is looking for those matches, looking for those signs of fraud, and nothing else. So that's why I say the opportunity is to do things that would just have been impossible before, even if the actual algorithm is absolutely trivial. It's like, does the same car identifier appear in two places at once? That's all it is. But you want to know that's the only thing that's going to happen, and the data can't be misused. And that's what this technology gives you.
How are CDOs kind of implementing this, in their daily, practice and what they do on a daily basis, right? Amongst their teams, amongst the company.
So that's where it gets interesting, because you then and this is where I have to be careful, because I get so excited by this technology, and I sort of I talk about the potential, but the reality is this technology, frankly, in certain guises is still quite hard to use. I said at the start of this this discussion that this technology came from the hardware industry. It came from the chip manufacturers, people like Intel. The kinds of people who can use a chip without any support for the software on top. Those people are pretty special. But if I'm the CDO at an insurance company working with the head of claims trying to drive down fraud, we're business people. The people working for us who are technological or application developers, but they know high-level languages like Java and things like that. They're not systems programmers who know how to program an Intel CPU. So there's kind of this gap between the potential of this really powerful technology that I think people don't yet realize exists, and the people who can benefit from it. There's the gap between the potential and the ability of people to exploit it. And frankly, that's where I sit. That's where Conclave sits. So the product that my firm has built, the team that I lead, it was really trying to solve that problem. Can we make it possible for business people and the technology people who work with them to build algorithms like that insurance one I just gave? Write them in high-level languages, Java, JavaScript, Kotlin, whatever you like, and then let the software, let Conclave in our case, compile it down, handle all the complication, so that all the stuff that makes it too hard to deploy is just hidden. You write your business logic, we compile it down to something that can run, and then you just stick it in the cloud and you're done. So I see myself as trying to bridge those two worlds, because there's this insanely good technology at the bottom, but the people who need it don't even know it exists. And absent something like Conclave, even if they did, they couldn't use it. So that's kind of the mission I'm on, is to bring those two worlds together.